Hi and hello, I am Athena Pondian here. Welcome to the basics of biomedical class. Yesterday itself, we are just successfully completed our first recall section of the first unit. From today onwards, we are going to discuss about each and every electrical components in the described manner. So, what is the types of it and what is the use of it, how far this particular components are very helpful for the circuit making, all the things we are going to discuss each and every topic. So, in that way, today we are going to discuss the first topic of the first unit, that is basics of biomedical, resistor. So what is resistor and what is the formula and how we can able to use this particular resistor in the circuits and what are the types of each and every resistors, all the things we are going to discuss today. Come, let me start the class now. In accordance with the resistor, what are all the things we are going to discuss today is, in accordance with the resistor, so topic today we are going to discuss about, what are the topics we are going to discuss today is, what is resistor actually, and how it can be represented in the formula in the alphabetical letters and also in the diagrammatic notation, how it can able to represent the resistor, and the third we can able to discuss about what is the use of this particular resistor, and what are the types of this resistor, and last how we can able to determine the color coding of the resistor. Using that, how we can able to determine the value of the resistor, all the things we are going to discuss today. So as a biomedical engineer, we should know all these points very carefully, because once you are going for any electrical circuits or when you are going for any medical equipments calibration, you need to know the basic electrical components. This particular resistor is very important to calibrate it over any medical sort of equipments. Okay, so let me start. What is a resistor and what are the questions we are going to discuss about today. Okay, before we are going to start the resistor, we must know the major types of electronic components, because each and every electronic component is coming under any of these types what you are going to discuss. So that is one is active elements, another one is passive elements. These are the major type of the electronic components. In that way, this resistor is coming under the passive components. So what is active and what is the passive electronic components? See, active elements are can able to give energy in the way of voltage or in the way of current or in the way of power, whatever it may be. Active components, that active elements can able to provide energy to the circuit, but the passive elements can't able to give the energy. It can able to receive the energy. Okay, that is what it can able to receive the energy, or it can able to absorb the energy. So elements that are giving the energy to the particular circuit in the way of voltage or current and whatever it may be, that are called as the active electronic components. The elements can't able to supply energy. The elements can able to absorb or dissipate that particular energy themselves. That are called the passive elements. So examples of the active components, or we can able to say the transformer, we can able to say the amplifiers, are all the examples of the active electronic elements, because it can able to give the energy. The passive elements and examples, all the basic elements like a resistor, capacitor, all the thing are coming under the passive electronic components, because it can't able to give the energy, it can able to absorb the energy, or it can able to resist the energy. So this is the example of the active and the passive elements. This is the major difference. You should know that what is an active and what is the passive electronic components. Okay, so in that way, this resistor can't able to give any energy. Of course, you all know that resistor is a passive electronic component. It can't able to give energy. It can able to absorb the energy to the particular circuit, because the main application of the resistance is it will resist the current. For example, is the circuit, if you are putting any resistor over there, that particular resistor will resist the current supply. It will reduce the voltage, or it reduce the current of the particular circuit. That is the main job done by this resistor. That is why, because of absorbing the energy, because of not giving the energy to the circuits, this particular resistor is coming under the passive electronic components. So what is a resistor? Actually, a resistor is look like, it is look like this. This is a two-terminal electronic component. Please remember, resistor is a two-terminal electronic component. Which electronic component? It is coming under the passive electronic component, because it can't able to give any energy, any sort of energy. It can able to absorb the energy. Okay. So this is the basic introduction about the resistor. Resistor is a two-terminal electronic component. Which electronic component? Whether it is active or passive, it is a passive electronic component because it can't able to give energy, it can able to absorb the energy. This is the resistor introduction. Here, this particular resistor, what is the purpose of this resistor is, this resistor, that is a two-terminal passive electronic components having a capability to reduce the current flow in the circuit. It will reduce the current flow in the circuit. For example, in any sort of the circuit, if you want to reduce the current level of the particular circuit, we need to place this terminal in between the circuit. If you placed over this particular resistor in the circuit, the resistor can able to cut it off, that is drop down the current that is flowing through the circuit. That is a very important purpose of this particular resistor. So what is the, how we can able to represent this resistor? The electronic symbol of the resistor is, electronic symbol of the resistor. This is the electronic symbol of the resistor. We are, probably we are using the alphabetical letter for representing the resistor as capital R. Okay. So who invented this particular resistor? It is invented by Mr. Ohm. So that is why this resistor unit is Ohm. The Ohm can be represented in the way of this particular symbol. Okay, so this is the alphabetical notation of the resistor and this is the electronic symbol and this is the Ohm, that is the unit of the resistor. Okay, how we can able to calculate the resistor? For example, there are so many different calculations, there is so many different values of resistors are there. How we can able to identify the values of the resistor? According to the Ohm's law, of course we know that Ohm's law is nothing but V is equal to IR. It's a basic thing, we all know that. Okay, so V is directly proportional to IR, that is the Ohm's law. If you want to calculate this particular resistor value, we need to do this. Through this we can able to identify how sort of this particular resistance value is. Resistor value is. So using this we can able to calculate the resistor value. Okay. The next important topic is resistor value. The calculation of resistor value is very important because once you go for the resistor value, according to that choosing of the resistor value only, the current flow in the circuit can be dropped down or we can able to cut it off that particular current flow. So in that resistor, the value of the resistor can be called as a resistance. Because we already know that according to the Ohm law, V is directly proportional to IR. So if you want to calculate the resistor, that R is equal to V by I. So if you want more current, the resistance value should be minimum. If you want less current, the resistance value should be high because R is inversely proportional to I according to the Ohm's law. So if you want the current flow in the circuit should be very minimum, you should be add much higher resistance value in that particular circuit. So that is the thing very important. So according to the choosable of this particular variation in the resistor, resistance value of the resistor, we can able to broadly classify this particular resistor into two different types. One is fixed resistor, another one is variable resistor. So of course the name itself shows that the fixed resistor we can't able to vary the resistance of that particular resistor. Everybody says that commonly he says that the notation of this particular thing is commonly called as the resistor, that is fixed resistor. Okay, we can able to figure the resistance value of this particular resistor is fixed. We can't able to change, we can't able to vary the particular resistance value. Each and every value of the resistor have different sort of two terminals devices, carbon composition component are there. So that is what the electrical component which are coming under the resistor, the can't able to change the value of the resistance are coming under the fixed resistor. There are some other resistor. We can able to adjust the resistance value according to whatever we need. Okay, so that kind of resistors are coming under the variable resistor. We can able to take an example of the potentiometer is one of the variable resistor. The rheostat is one of the variable resistor. In the circuit we already saw over. Okay, so that are all coming under the variable resistor. So whatever the need we required, according to that we can able to choose the resistor, whether we need a fixed resistor or the variable resistor. In as a biomedical engineer, we are using mostly we are using this particular variable resistor. for troubleshooting any of the medical equipments, we probably go for the variable resistor. For the project level determination or for the prototype determination, we can able to go for the fixed resistor. There is a breadboard connections and all. We can just go for the fixed resistor. It's very comfortable. But we are go for the advanced level. We are go for the medical equipment devices. We want to troubleshooting that particular devices, whether the leakage is there or not. We want to identify the right. We are using this variable resistor. It's very comfortable for you to determine whether the circuit leakage and everything. Okay, so this is the major type of the resistor. Then, what is the next topic we are going to discuss about is, apart from these particular points, apart from this brief introduction about this resistor and the types and everything, what are the other important points? Apart from these types of the fixed and variable resistor, what are the other types of there? And what are the component that is very useful for the medical applications, all the things, and how we can able to identify the value of the resistor without using any multimeters, how we can able to identify the value of resistor using the color coding, all the things we are going to discuss in this video.
Characteristics and construction. Fixed resistors have a constant resistance value and they are the most common type. When people talk about a resistor, they most probably mean a fixed resistor. The picture shows an actual carbon film resistor. Fixed resistors are available in axial and SMD packages. Variable resistors have an adjustable resistance value. Most variable resistors are adjusted by mechanical movement. When they are used as a variable voltage divider, they are called potentiometers. When they are used as variable resistance to control the current in the circuit, they are called rheostats. Digital potentiometers are controlled electronically instead of by mechanical action. A third category are resistors which have a varying resistance dependent on a physical quantity, such as light, temperature or voltage. They are often used as measurement devices. Another breakdown of resistor types can be made according to resistance material and construction. Wire-wound resistors are the oldest type which are still used today. They are constructed by winding a resistive wire around a non-conducting core. They can have very low resistance values and can be produced fairly accurate. Furthermore, they are very durable. A disadvantage is the parasitic reactance for higher frequencies. Carbon composition resistors are constructed with a mixture of a non-conducting ceramic and fine carbon particles. They are also very old and used to be the most common resistor type a few decades ago. Although their properties are inferior to other types, regarding for example tolerance, they are still in demand for certain applications. For example, they have the ability to withstand high energy pulses. Carbon film resistors are widely used today. They are made out of a non-conducting core with a thin carbon film around it. Carbon film resistors have a higher accuracy than carbon composition resistors, but have inferior properties compared to metal or metal oxide film. Metal film resistors have a similar construction as carbon film resistors, but have a metal layer instead of a carbon film. They have a better accuracy, a lower temperature coefficient, and a fairly good stability. Metal oxide film resistors are even more durable and have a higher temperature resistance and reliability than the metal film resistors. Foil resistors have a resistive element of a thin metallic foil of several micrometers thick. They have the highest available precision and stability today. Most axial leaded resistors have a marking with colored bands to indicate the resistance value and tolerance. This resistor is a carbon composition resistor with 4 color bands. The first band gives the first digit of the resistance value. The second band gives the second digit. The third band indicates a multiplication factor, and the fourth band gives away the tolerance of the resistor. You can try to memorize the meaning of each band and color, but you can also use the resistor color code chart to decipher the code. At resistorguide.com you can even find an automatic calculator to decipher the code for you. Using the chart, we see that the first red band has a value of 2. The second blue band is 6. The third band is gray, which means a multiplication factor of 10,000. The golden fourth band means a tolerance of 5%. We know that the resistor has a value of 2.6 megaohms with a tolerance of 5%.
So this is the basic requirement that we need as a biomedical engineer. So this basic requirement of each and every electronic components is very comfortable for you. Once you know about these basic concepts of each and every electronic components, then that is very comfortable for you to go for any prototype developing in for the upcoming medical devices, or if you want to troubleshooting any of the medical equipment, these sort of the basic knowledge you should have. And rather, once you're crossed over all these basic knowledge, once you're finishing almost 10 to 15 topics up to 15 electronic components, the theory part, then we go for the analytical problems. Analytical problems in the sense how we can able to calculate this resistance value in the circuit, how we can able to frame the circuit, all the things we are discussed later. Okay, first of all, you should know that the basic requirement of these kind of resistor, what we are discussed in this video. Okay, so in the next class, what you are going to discuss about is the next electronic component, that is capacitor. So what is capacitor and what are all the things we have crossed over for the resistor? We have same thing we are repeated for the capacitor also. So hope so I understand this particular resistor value and resistance, how we can able to calculate the resistance, all the thing. So in the next class we will meet. Thank you very much.